Okay, our goal is to determine a sample size for an experiment that we want to conduct. In that experiment, what we'd like to do is impose on a group of animals this group B model system and hopefully induce stress in the animals, and then we'll measure that stress that we've induced in the animals by measuring plasma corticosterone levels. Now, it turns out that in normal animals, their plasma corticosterone would be 129 nanograms per mil. In our stress system, we hope to elevate that, and what we're really looking for is the ability to elevate that significantly in a very reliable way. Okay? So we have this data. Let's look at the statistics of the data. And with that, we have a mean corticosterone level of 135 in the plasma and a standard deviation for that mean of 40.39. So let's remember that, and let's move to our power calculator, GPower. And so we've opened it up, and here's basically what it looks like right here. We've got this test, these things to do. So the first thing we have to do is select the kind of statistical test that we anticipate doing once we run the big experiment, and that's going to be a t-test. And it's going to actually be a specific kind of t-test. It's going to be a t-test where we're basically measuring the difference of our mean to some constant. In this case, the constant is 129. So we put that in there. And then the next thing that we want to do is we want to select the kind of power analysis we want to do. We have 5 options here, and the option that we're selecting is a priori. So what a priori is computing a required sample size after inputting alpha, power, and effect size for the experiment. And so let's get rid of that. You don't need to see that yet. We're going to run an experiment where the alpha is 0.05. We're going to run an experiment where we want to power up so that it's basically 80%. We're willing to accept 20% type 2 error, in other words. We know we're going to do a two-tailed test. The reason we're going to do a two-tailed test is because Prism only allows me to do a two-tailed one-sample t-test, so that's what I'm going to have to power up for. And now what we have to do is calculate the effect size. So the way we do that is we determine it using a simple calculator right here. And in this calculator, I've inputted the mean expected value of our model Group B model system, the reference or standard value, the null hypothesis, if you will, of 129. So normal unstressed animals would have that value of the hormone, and if I stress them appropriately with my model and consistently, I would expect at least 135. So the question is, what is the effect size? Well, you can calculate it simply by doing this, but I can tell you how it's calculated, and that's simply taking the difference between this mean and that mean, and then dividing that difference by 40.4. So if you do that very quickly, you would have come up with a value of 0.1559, etc. So I need to put that value here, and GPower allows me to basically calculate it, then calculate it again, and transfer it over into that window. So there I have it. I'm all set up. I have my effect size, I have my alpha, I have the power that I'm hoping to achieve. All that's left for me to do now is to calculate the sample size. And the way I do that is by hitting this button right here. And there you have it. So to run an experiment at 80% power with 5% alpha, the sample size I would need would be 325. In other words, I'd need 325 rats to conduct this experiment. Okay? So that's one thing you could do with GPower is you can calculate this a priori, before you do the experiment, how big is this experiment going to have to be? And so you can use it to basically calculate your sample size like that. Now, you can also do post-hoc sample size analysis. And so let's just do the same, keeping the test the same. It's a t-test. It's a one-sample t-test. And let's just kind of play around with that. So let's imagine that, well, let me switch to that right now. So let's imagine that we had let's determine what the power was of our preliminary experiment that we ran. and see just how that was. So we have the same effect size. This is just what we've calculated here. Let's say that we ran it at 5% and we had 32 samples in that. So if I calculate that right there, what I get is basically the power of that experiment. And it turns out that that power was about 13.7%. And as you can see, that's fairly low power as you look up at it graphically. So you can do, with GPower, you can basically do a lot of different power analysis, 5 different kinds of power analysis, but the ones we'll most talk about in this course are basically going to be a priori and post hoc. Now, I urge you to take a look at these other things that you can do with this and play around with them, and you'll see that this is actually a fairly sophisticated tool that you can use not just now for this course, but you can incorporate it into your research as well. And begin, if you're not already doing it, begin to really do really nice, well-designed, and well-powered experiments so you don't waste too much time doing crappy experiments. All right, thanks for listening.